Let's get started. All right, so today I wanted to cover the concept of HTTP. Maybe we should have done this yesterday, but we're doing it today either way. And HTTP is the web's protocol. This is how the web talks to each other and how different resources on the web go back and forth. So HTTP stands for Hypertext Transfer Protocol. So it's a transfer protocol for hypertext. And hypertext is nothing more than just text with links in it. That's it. That's the definition of hypertext. It is nonlinear text, which means that it's text that when you when you're writing, you can put links inside of it, and those links can lead to external resources. The same thing can be done with pictures now. So when you click on a picture, it can go to an external resource. But yeah, that's essentially what it is. So the protocol goes back to 1991. That's right around when the intranet was founded. Intranet meaning internal internet rather than the external internet. And hypertext in general, it goes back to as early as 1930. Wall of text, essentially the big points are that HTTP, the protocol in general, was just to transfer hypertext back and forth. And that's just text with links in it. Today, the modern equivalent is HTML, but you can also transfer other things over the internet using this HTTP protocol, including images and CSS and JavaScript and responses. Like you can send, it's just a protocol to send stuff back and forth, but it is the underlying protocol that the web uses. So in every single conversation that you have in your everyday life, there is a client and there is a response. There's a client and then there is a server. The client is the person making the request, and the server is the one giving the response. So if I go up to Kyle and I go, how's it going? And I stick out my hand, I'm a client making a request to Kyle. So I'm the client, I'm making a request. Kyle is the server. He acknowledges me. He sees that I'm not angry, I have a handout, that's a sign of friendship. And then he processes that information and responds with, yeah, he shakes my hand back and says hello. Hello. And that's about all there is in terms of like a very basic HTTP conversation. It is one person making a request. So I stick my hand out at Kyle, and Kyle is the server. The server parses through the request that comes in, which is, okay, this is a person looking at me, hands stuck out, no fist clenched, no weapon in their hand. It's just, I'm recognizing that as a sign of, I'd like just a friendly hello. And then he responds accordingly. When you go onto any sort of website, you go to like Amazon.com, you're the client. Your machine, this thing right here, that's the client. It's making a request to Amazon.com. Amazon.com says, okay, what are you asking for? Okay, let me get all that information for you, wrap it up real nice, and then send it back to your screen. That's all there is. So client and server. Now, underneath the hood, in terms of conceptually, it's easy to understand. One person makes a request, the other person makes a response. But in reality, it looks like this. It's just a bunch of strings put together. The request line is going to look a little bit like this, and the response looks a little bit like that. We're going to go over each one of them. The first line at the very top is the request line. Now, there are different types of requests that you can make. Now, remember, computers are very, very fast, but they're very, very stupid. So when I stick my hand out at Kyle for a handshake, there's a lot of processing that he has built into his head. He knows that, okay, based off of, if you were to think very programmatically, based off of my experience, when somebody walks up to me and puts out their hand, and I analyze the rest of their body, and they're not trying to fight me or anything like that, I see this as a act of kindness or an act of friendship or an act of like peace in general. There's a lot of things that we kind of as humans take for granted. Now, if I was to walk up to Kyle with a fist clenched and everything, there's another series of unspoken things that he knows that I'm about to punch him in the face. The computers are not that smart. You have to be very explicit with every single thing. So whenever you make a request, you literally have to say, follow this kind of architecture. The first thing that comes up is the request line, and that's broken up into the method, the URI, which is the / whatever at the end, and the HTTP protocol version, which is currently 1.1 for the entire web. So there are multiple HTTP verbs and these are the ones that you will need to memorize for the sake of your interviews and just in general for longevity. So when you make a request to somebody, there are basically 5 big actions. One of them is get, which basically says, get me this information. So whenever I go to gmail.com and press enter, that's basically saying, hey, Gmail, get me this information. Amazon.com, get me this information. If I'm sending something, like I fill out a form and I press submit, I'm sending information to the server. That's going to be a post request. So if I wanted to give, whenever you need to type something in and press enter, that's a post request. Whenever you don't submit a form and just press like some button, that's generally a get request. So get, if I go to Amazon.com and I look up shoes and press enter, that's going to be a post request. But if I just go to Amazon.com and don't type in anything, it's going to be a get request. Sometimes you want to delete your, sometimes you just want to delete everything for your account and you want to make a delete request. That's going to be a type of request coming through. It's basically you're being explicit. The type of request that's coming through is a get request. I want you to get me something. The type of request that's coming through is a post request. I'm sending you something. The type of request that's coming in is a delete request. I'm deleting something. There's one called put or patch that's not on here. That's when I want to update something. And then finally, head is basically I want to retrieve information about what lives here. So put or patch both work. So it's get, post, put, and patch are synonymous, and then delete. Those are the big 5 that you need to memorize. So if I wanted to update something, Juan, what would I use? Put or patch. Christian, if I wanted to delete something. If I wanted to retrieve a resource, retrieve something from the database. Get. And then if I wanted to send something, post.
Could you give us an example of head?
I've never used head.
Okay, cool. That's all I need to know.
I've never used head. I should probably update these slides. All right. So that's the first thing that comes up in the request line. It's just the verb. It's basically the type of request that's coming through. The next thing that comes through is called the uniform resource identifier. And you can differentiate a uniform resource identifier from a URN and a URL. So the URI is the most specific thing. Once you get to a particular, let's think of Amazon.com as an address. But Amazon.com is a giant warehouse. Specifically, where are you trying to go? I'm trying to go to /bio/HTML. Okay, so once you get to Amazon.com, there's a URI, a specific location where /bio/HTML lives. The URN includes the host and the URI put together. So Amazon.com is the host, URI is the bio.html. Those 2 things put together is the URN. And then URL is the full thing. The protocol, which is the HTTP, the host, which is Amazon.com or example.com in our case, plus the URI. So these 3 things put together will give you that full URL. Now, one quick thing that's not in the slides, but what's the difference between HTTP and HTTPS? Security, yeah. So just whenever you see that S at the end, you know that you're submitting stuff as securely as the web allows for right now. So if you ever go to like chase.com and there's no HTTPS, if there's no S in the HTTP, you're probably not actually at chase.com. So you always want to make sure that whenever you're doing anything secure, you have that S inside the URL. And whenever I go to Google Chrome, you can tell because there's that S right there, and there's also a lock button on the left. That basically means that you are secure at that point. Any question? No, sir. No? Okay. All right. So we covered the request line. That's what comes in your HTTP request. There's also something called headers, and these are explicit things that you're passing in that the server needs to know. So you have the host, which is exactly what we talked about earlier. It is that actual something.com or something.edu. That's the actual host. And then we have user agent, which is Google Chrome 5234. So this basically, as you can tell, says this is the type of machine that's making this request. And this is important for a number of reasons. One is if you are making a request on your phone, the response they give you is formatted in phone format so that you can actually read it on your phone. You've all been to like, if you go to ebay.com on your phone right now, and you can try this now or you can try it later if you want. If you go to ebay.com on your phone right now, it's going to be a huge desktop like resolution, and it doesn't fit on your phone. And that's because they have apps. But in general, whenever you make a request from your phone, it's sending over, hey, the user agent is Google Chrome for iPhone. So it's going to be formatted in such a way that it looks good on your particular machine. It's also important because, okay, so I used to work at this loan company, and this loan company has people of all different, backgrounds. You got white collar doctors who need loans. You got, super blue collar people who are, just need money to make ends meet. And every now and then we get a request from like this, unfortunately, stereotypically speaking, the older grandmothers, and they're like, it doesn't work on my machine, and that's the help request that comes in. So what we have to do is we have to find their request, but luckily we know what their user agents are. And almost across the board, it was someone operating Internet Explorer from way back when. Now, when you operate Internet Explorer from way back when, and you have all the metrics of all the requests that come in, you can make those types of business decisions of, okay, we want to update this to hit the most number of customers so that it looks really good on those particular things. You can't make those types of business decisions if you don't have metrics. So if I know that 40% of my requests are coming from Google Chrome and 1% is coming from Internet Explorer, I'm not going to do Internet Explorer first. I'm always going to do that Google Chrome first because I have those metrics. So that's why you want to capture the user agent as well. Sometimes you're going to be sending, most of the time the web traffic is GET requests, but sometimes it's going to be POST requests. Sure.
When you say metrics, you mean like keeping track of all this data and like having it?
Pretty much, yeah. So
okay,
most major companies will keep track of every single request that comes in, and they save each request inside of a database. Now that database is going to get enormous real quick, but it's really important because then they know we need to optimize for Google Chrome or we need to optimize for Firefox, because one bad decision means that you could, if 40% use Google Chrome and 15% use Firefox, but your developers are like, everyone uses Firefox, you've just lost 25% on that particular project right away. Next, we have this HTTP request. It might be a POST request, and this is what a general POST request looks like. So I'm going to do a POST / whatever this URI is with this HTTP protocol, and that's always going to be 1.1. You still got that host, you still got the user agent, but you're when you send stuff, you're sending the content type of what I'm sending is going to be in encoded form from the web. You always have a blank line after that, and then sometimes you have a body. It's going to be optional because sometimes you're not sending an encoded form, but what we've got here is we've got a form, and then we're looking for new Jordans, and the color is going to equal red. Whenever you have a query string, so if I go back over here, and I open up, I don't know, what's footlocker.com. If I go to footlocker.com, well, we have the protocol HTTPS, so we know we're sending stuff securely. No one can read what I'm doing. If I want to go to men's shoes and I want to go to bestsellers, I'm not really into shoes. Let's say I want this one. Actually, no. I'm gonna search for what's a very popular brand of shoe. Any specific one? Yeezys.
No, that's a third brand. I thought Jordan was
Sure. But that's not the point I'm trying to make. So we have this URL up here, and then if you ever see this question mark in the URL up at the very top, this is basically so that you can copy and paste this, and then it will make a GET request and automatically fill in. The query is going to be, I'm looking for Yeezys. You'll notice that Yeezys doesn't show up like this because there's no apostrophe inside of URL UTF encoding. It's actually %27. I guess translated. You don't need to know that, but that's why it's %27. So you can use two different types of links to get here. One of them is to just copy this, and I can make a GET request because I'm basically saying, get me this particular resource, and I'll get the exact same thing on this page on tab number 2 as I get on tab number 3. I'm also going to post a new one for, like, I don't know, CrossFit shoes, because that's what I actually look for. And you can kind of see there's a new query up here. So it's anytime you see a question mark, the thing that follows is going to be a query string. So I've got query equals CrossFit, and then there's no space inside of URLs, so I'm going to do %20, and that's where the shoes comes from.
Is there a percent equivalent to every question character?
Yes. I don't know what they all are. Yeah. But yeah, that's this thing down here. The query parameters are separated from the URI with a question mark. So the moment the question mark starts, the thing that follows is going to be a query string. That's the protocol that goes across the web. We talked. Okay, so these are some more headers that you could send over. Basically, if you are, we are in the U.S., so we write things in English and Spanish most of the time. But if you're across the world, if you want to do something in Chinese, you're basically saying, I'm going to make a request to this particular URL, and the only thing I'm willing to accept back is Chinese. Then the server knows, okay, I need to translate this whole thing into Chinese before sending it back. And then also, what are you willing to accept? Are you willing to accept just plain text? Are you willing to accept an image or JSON or HTML? What are you willing to accept back? You can be explicit with that one as well. So now we're talking about, we did half of it, which was the HTTP request. And the other half, we have the HTTP response. It's broken up into status line, headers, blank line, and then an optional body. The status line is broken into the status code, a reason phrase, and HTTP version. Again, this is always 1.1 for right now. Now, Mike still remembers this. I use the same dating metaphor every single time. So who is still on the dating scene, like not in a committed relationship or married? All right. What is your pickup line of choice? Hi, I'm Bobby. I think you're cute. Do you ask a question? What's your name? Okay. Or let's say, like, what's your name? Can I buy you a drink? Or something like that, right? Or just what's your name?
Yeah.
Okay. So Bobby's at the bar or the club or wherever he is trying to meet people, and he says, "Hi, I'm Bobby. I think you're cute. What's your name?" Now, there's a whole bunch of responses that can come back, but you can categorize them into 4 different ones. One of them is, okay, my name is, whatever the person's name is. I'm also interested in you. Yes, you can buy me a drink. That's the 200 status code. There's also a 400 status code, which is anything that's bad. So if Bobby goes up, "Hi, I'm Bobby. I think you're cute. What's your name?" No. Just flat out no. There could be a whole bunch of things, the reasons why, but we're looking at the first number. So there's, I don't know, a couple hundred status codes, but we're looking at the very first number. If the status code response starts with a 4, that just means no. It could be, "Try again, man," or like, "You're unauthorized to ask this because I'm Beyonce. You can't ask me that question," right? Or 404, I don't know. There's no good one for this one. So 200 is, "Yes, Bobby, like, my name is John. You can buy me a drink, sure." And then the other one is 400, which is absolutely not. I'm just not interested. There's 2 other ones that could go as well. The 300 is, "I acknowledge that you said something to me, but I need to redirect you somewhere else." So if you go to google.com, it redirects you to HTTPS, www.google.com. So this is Bobby going up to some person, and he goes, "I'm Bobby. I think you're cute. What's your name?" "Hi, Bobby. Let me introduce you to my friend," and the person next to them. That's a redirect. So anything starting with a 3 is a redirect. And then finally, there's a 500, which is an internal server error. This is, "Hi, I'm Bobby. I think you're cute. What's your name?" "It's not you, it's me. I had bad food poisoning. I just got out of a bad relation." It could be a variety of things, but it's an internal server error. So the person receiving Bobby's, advances is saying, like, "I acknowledge that you said me something, but I can't respond right now for some reason." And this generally happens at 2 or 3 o'clock in the morning. If you are, like, if they're doing maintenance, like if you ever go to, like, or Chase.com says, "Oh, we're going to be out for these periods of time," and you can't log in. That's an internal server error because they know that they're having maintenance. These are another set of things that you need to memorize. So the first one is the amount of, what's a GET request? Yeah, I'm getting something from the server. What about a POST request?
A POST request is when you're sending something.
Okay, what about a put and patch? Put in patch. Update and delete. Delete. All right. So those are the verbs that you need to memorize for the HTTP request side. And on the response side, you need to memorize 2, 3, 4, and 500 level status codes. You don't need to memorize every single one, but you need to memorize the first number. So what's a 200 status code?
Okay.
What's a 300 level status code?
See other.
See other, redirect. What's a 400? Not going to happen. At 500, Christian?
Internal search.
Yeah. So 200, yes, I'd like to go on a date with you. 300, I see you. Let me introduce you to my friend. 400 is no. 500 is not you, it's me. So that's the first line. This is status line right over here. So they're also going to send some response headers back, including, what I'm sending back is going to be a specific content type. It's going to be HTML, or it might be an image, or it might be JSON. How long is the thing that I'm sending back? Am I sending back any cookies that you need to memorize? And then when was the response set as well? So all this stuff comes back to your machine, and your Google Chrome parses it and then displays it accordingly. There's a lot of HTTP conversations happening on every single page. So let me show you this in real life. If I go to target.com and I open up the Chrome tools and I hit network, and I clear everything out. Let me clear everything. All right, I'm going to make one request to target.com. Underneath the hood, it's not just one thing that's happening. Take a look at the bottom left-hand corner if you can. There are already 87, 88, 91 requests being made in the background for everything that shows up on this one page. So target.com is not just reaching out to target.com, because target.com, they realize in the background, I need to get this particular JavaScript file, and I need to get this particular image of swimwear, and I need to get, this other picture, that's the same picture of swimwear. I need to get whatever this kind of JavaScript is in order for this web page to load properly. One request to target.com actually triggered off 93 other requests in the background to make this page look the way that it is. So it's not just one thing that's happening per page. Now, one thing I will say about cookies, because we saw that right over here, is that there's a frightening amount of stuff that they know about you. Where are my cookies? There it is. So these are the cookies that are stored whenever I visit target.com for the first time. If I wanted to clear it out, I could. Let me just clear it out. So now I have no cookies associated with Target. Now I'm going to go there. And now they know a few things about me. They know my guest location right away. So they already immediately know where I'm from. You're shopping closest to Chicago State Street. Ooh, how did they know that? It's because they send over, when I make a request over to target.com, they respond and set a bunch of cookies in my browser to make my life a little bit easier. You can see I'm calling from 60603, which is actually our address, at this lat and long. So they know exactly where I am when I'm making these sorts of requests. So that's some stuff that's saved on my end. There's another user location. I'm in Illinois, US, and all of this other stuff I don't really know, but it makes my life a little bit easier as a consumer. It's also a little bit dangerous, but that's okay too. Any questions? Oh, I got locked out. Oh no, I cleared my cookies. All right. Hold on, let me pause the recording real quick. One thing that you have to know about the web is that it's what's called stateless. Stateless meaning that it doesn't keep track of who you are. So there is a cinematic classic, speaking of Adam Sandler and Bobby Boucher this morning, called 50 First Dates. If you're not familiar with the movie, Adam Sandler goes down to like Hawaii or something, and he meets this girl that he thinks is very attractive, Drew Barrymore, and Drew Barrymore has amnesia. So she doesn't remember anything prior to a certain point. So he introduces himself, they go on a date, and the next day she doesn't recognize him. So that's the concept of 50 first dates, because she said it takes me about 50 times to like do something over and over again before it kind of gets locked into my brain. And that's kind of how you have to think about every single HTTP request that you're making. Every single time you make a request to Google.com, even though I go there 100 times a day, it's like they never met me before. So it's just like a fresh start every single time. But like at the end of the movie, Adam Sandler and Drew Barrymore get married, they have a child, and every morning she has to play like this VHS video basically saying like, we actually got married, this is the person that you're about to see, this is your daughter, like this is all the things that happen in your life. She needs little like cookie crumbs to kind of like piece everything together. And that's the idea behind cookies. So every single time that you make a request via HTTP, it's brand new. But you have cookies that are being sent back from the, speaking of cookies, you're being sent back cookies from the server to basically say like, oh, this is like, you're logged in, this is what you were looking at last, this is the things that are inside of your cart. So actually, I think I can tackle what you were talking about a little bit earlier. So let's say I go to Target and I want to buy lawn furniture. I only go to Target.com for this class. So I want a patio set, and I want to. Oh my gosh, this thing forever. I'm gonna just add to cart this Latigo 3-piece patio set. I actually really like patio furniture. Like if I could like put patio furniture inside my house, if it wasn't like super gross, I would like to do that because I think it looks nice. But what's that? It's not a good idea. Okay, so I'm not logged in. We can all see that because I'm not logged in over here. And every single time that I make a request to Target.com, it's a fresh request. They don't actually know that I've looked here before. But if I open up another tab and I go to Target.com again, even though it's a brand new request that's being made, what's that in my cart? Is that Latigo 3-piece set. How did it know that? Because every single time it's supposed to be a fresh request. They don't know who I am. They're not tracking who I am at all. This is where cookies come into play. There is a cookie somewhere on my machine, somewhere inside of my Google Chrome that basically says, oh, they added this to their cart. So it makes my shopping experience a little bit easier. If I were to either close the cookies, clear the cookies, or open up a new incognito window which doesn't have any of those cookies, I just go to Target.com. Same machine, same Google Chrome making the same request to Target.com, but you'll notice that on the one where the cookies are saved, the non-incognito one, I don't have anything in my cart. The concept of a cart, though, to Christina's point, if you were to sign in and save this inside of your cart, that is actually saved to your particular username. So that whenever you make a subsequent request, since it's already associated with your username, if I log in here with cookies, and if I log in incognito without cookies, I'm still good. So a little bit, you're going to learn more about cookies and how they work, because I'm pretty sure that's part of the challenge either today or Monday. But here's the summary. You make a request to the server, and the server sets cookies and sends them back as part of the response. Your machine, just your Google Chrome or your Firefox, stores those cookies. Server doesn't store any cookies, but in any subsequent one, you are sending those cookies over as part of subsequent requests. That's why whenever you log in on Google, you don't have to log in again for another 2 weeks. They send you a cookie that expires in 2 weeks, and every request that you make over and over again says, okay, I am logged in as this unique person. Yeah, that's a little bit about the HTTP protocol. Big things: get, post, put, patch, delete, and 2, 3, 4, and 500 level status codes. A fun site for you to visit, and then we'll take probably a 5-minute break because this is very heavy stuff. Fun one is HTTP status codes dogs. Or there's also ones for cats if you like that one too. So they have different, pictures of dogs with different status codes if you ever are wondering what they are. So it's like, this dog is clearly happy, everything is okay. That's a 200 level status code. If I jump down to 403 forbidden, You know, this is a forbidden thing. Or 404 not found. This dog cannot find the bone that they were looking for. So you can see there are, you know, dozens, and you know, just a few dozen status codes, and nobody needs to memorize all of them. You can if you want to, but you can just look over here as well. There's also a weird one called
206 is partial content with the three-legged dog.
There's also one called I am a teapot, HTTP status code 418. That one's just kind of like an Easter egg that they put in there. It doesn't serve any real purpose. I think they threw it in as an Easter egg a long time ago. Go down.
No, click on it.
Click on it.
I want to see that.
Yeah, it's just an Easter egg that they put in a long time ago. It's kind of stupid, but it is there. Yeah, kind of. Yeah. Okay, let's take like 5 minutes and come back, and then we'll go over HTTP server 1, and then we'll go over Beyond Tech, and we'll be done for today. So let's take about 5 minutes.